I will give a lecture on subcomputing approach and its application in engineering field. Now, as we are discussing about subcomputing, what is actually the subcomputing mean by? Earlier, we are having computer system where we use the binary logic, either yes or no. Now, the tendency of the scientific world is going towards intelligent systems. Why we are going for that? That is because we want to incorporate the intelligence level into the computer system. Now, I will ask you, what do you mean by intelligence? We all tell that human being is intelligent. Why? What is the difference there exists between a human being and other creatures? For example, an animal or some other thing. So that we are classifying human as intelligent and other one as less intelligent. Can anybody tell me? Basically, decision making, right. So, decision making, in other words, we can interpret it as adaptability to situations, right. For example, suppose on a fine day you are awaking and you feel uncomfortable, right, and your aim is you have to go to the office by 10 o'clock. Then what will be your immediate action? You will see what has happened to me. You will try to find out the cause for which you are feeling uncomfortable, right? Then one by one you will get the different causes. Am I having fever? No. Am I having dysentery? No. Am I having cold? No. Like that, one by one you will go, and finally you will achieve at a conclusion that, oh, today I am having somewhat fever. Okay. Once you get this conclusion, little bit, it may not be a perfect conclusion, then what you will do? If you are having a fever, then what will be your action? You will take a paracetamol or nice or something like that, so that the fever will reduce and you will be able to go to your institute. Then you will think of later on what has happened to you, right? But suppose after taking that paracetamol, you did not feel again comfortable, means the fever is not reduced. Then what you will do? You will definitely immediately go to a doctor, or you will phone the doctor, something you will do. Sir, this has happened to me and what I should do? Then he will give a expert decision. Because he is expert in that domain, you went to him, otherwise you would not have, right? So, after getting the advice from the doctor, you perform accordingly and you get your aim achieved. Your aim is reaching the office at 10 o'clock. So, in engineering term, we can interpret this as, yesterday you are in a one operating condition. Yesterday it was fine. Your system, as a engineering system, if you see, was in perfect position, was in a stable operating condition, but something has happened to your system in between, so that next day your operating condition has changed. So, in the new operating condition, to achieve your goal, you have to take some adaptability measures. You have to adapt your system to the new operating condition. Otherwise, you will not achieve your goal. So, this process of adapting to yourself, an engineering perspective, it is adapting to the system to perform the goal or to achieve the goal, is called as intelligent system. So, these intelligent systems are in a way mimicking the human behavior. Human beings as a whole, if you see, is having a brain, a decision making power, and reproducibility capability. These three things will basically categorize a human being. He has a brain. Using that brain and different experience he has gathered in between, he took the decision making and he want to maintain his race. So these three categories is divided, or in engineering perspective is called as neural network, physiology and genetic. Neural network is nothing but mimicking or trying to represent the brain in mathematical form. Physiology is interpreting the decision power or incorporating the expert knowledge into mathematics, and genetic algorithm is nothing but survival of the fittest, and which is nothing but maintaining the race of human. Right? So, all these three aims at a single point, which is adaptability or achieving to the goal. And we did all these mathematics, whatever you have done till now, is again to achieve something, and that is nothing but your goal. Right? Now, I will just touch something on neural network, physiology, genetic algorithm. Then I will come to my topic back there. Now, coming to neural network. Suppose a child is at 2 years of old and he is just starting his talking habit, right? And he is looking to a cow. What will be his immediate reaction? He will ask his elderly one that what is this? Answer will be cow. Next time when he is looking to that cow or that structure, so to say, can he identify? Maybe, may not. If he is very, very intelligent, so to say, IQ level is very high, he can identify that, yes, it is a cow. But if he is a dull one little bit, then he may not be able to identify. Then again he will ask. Answer will be cow. So repeatedly when he will subjected to that structure, at that instant or at the final instance after 50-60 exposure, he will be able to identify the structure. Yes, this is a cow, right? Now what has happened inside his brain, so that initially he was not able to do the thing, but now he is capable of. This is nothing but a training of neural network. You must have been exposed to that, I am not going into detail. Of the neural or neuron which is there in our brain with chemical structure. A chemistry happens or is going on inside our brain which excites some of the neuron, and a weight type of combination is there inside our neuron which identify this structure. Those things I think you have been told about. Neural network, yes or no? Okay. So I am not going into the mathematics portion. I will interpret it. Now, this cow, suppose let us assume that one leg of that cow is not there. It is a 3-legged cow. Earlier it was 4-legged. Now it is a 3-legged cow. The child can identify or not? 3-legged. I think it will be very easily identified. We are looking to many 3-legged dog which we are able to identify. Yes, it is a dog. 2-legged, maybe, may not be. So ultimately, let me assume that I will give the tail of that cow. Will it be able to identify? Never possible, whatever intelligence level it may have. Right? So in the engineering perspective, what is this interpretation? He was having many inputs. One by one, you are reducing the inputs. Up to a particular level, he can identify. It may not be perfect. Hesitation may be there. It may be suboptimal. But he will manage. But after a particular number of inputs, he will not be able to do the job. So this has a lot of engineering potential. In the sense, suppose you are having a controller or a industry is there, image processing or anywhere you take. You need many sensors. Suppose I want to control a process industry. I need voltage, current, speed, power, all things I need. So those things are sensed by sensors or transducers, and the output of those sensors and transducers are given to the computer and you get the decision, whatever may be the decision. This is the general phenomenon, right? So suppose you are having 20 transducers and you are taking a decision. If it is a conventional system, one transducer is failing, the output will be 0. Immediately it will say, no, I cannot do it. It will raise its hand. However, if you go by a neural network, since it is a parallel processing architecture, even if 1, 2 inputs are failing, you will get a suboptimal performance. I am not telling it is optimal, but it will be a suboptimal, but it will manage the show. Earlier if it was 100%, now it may not be 100, but at least 95% you will get. And this is being used in TISCO in a large manner. They are using this neural network phenomenon. GA they are extensively using in their data plan for many other things in the research domain. Okay. So one of the important advantages of neural network is its input handling. Even if the number of inputs are reducing by some percentage, it can manage the show, right? Now, you again come to that child. The child is trained by a white colored cow. The skin, etc. was white. Now it is a red colored cow. Can he identify or not? Without hesitation, I think he will be able to do it. Only slight color has changed. Other main features, main inputs are there, which is not changing. But some of the input, which is suppose the skin of the cow, that cow, which was the input earlier, has little bit deteriorated or changed. This is indirectly hinting to the noise phenomenon in engineering practice. Inputs are there, but input was 4 volt earlier during training, but that 4 has changed to now 4.1 or 4.2. Little bit change is there. It is not that from 4 it is going to 0. 4 going to 0 is the transducer is failing, but 4 is changing to 4.1. It's some error somewhere has been introduced, which is nothing but your noise in the measurement. So, a neural network can very easily tackle the noisy situation, but no doubt up to a particular level. It cannot take 100, if you make 100% noisy, means 0 dB noise, it may not be able to perform. But even in some of the features which may not be prominent, it can handle up to 100%. But indirectly I can say, if that feature is not prominent, then it is a redundant feature. You should not take into account that feature. Right? So these are some of the engineering perspective of neural network. Another is obviously, which you all know, that is nothing but training. Training means if you don't have a physical mathematical representation of that system, if you don't have a mathematical representation of a system, but you are having a data set, you can gather the information of the system, which is nothing but your training of the neuron. Right? That you know. Can you give me an example where it can be used? For an example, I am telling you. This fan, I want to design a controller for this fan. Right? So how will I go? I will first represent this fan in a state space model, x dot equal to ax plus b. Everybody must be knowing about this. DC motor, we represent x dot equal to ax, or any system you take, it is a differential equation. Right? Now, once you get this A matrix, that is called as state matrix, you will design your controller based on that A matrix. Now, this A matrix has been designed based on certain mathematics. That mathematics has been found with certain assumptions. Initially, we are writing lot of assumptions. Assumptions, saturation is not there. Assumptions, the flux is uniform. Assumptions, air gap is uniform. अरे air gap तो uniform नहीं है. How do you take that it is uniform? Right? So, in that case, what will happen? In 90% cases, you will get a successful result. Because those assumptions will not be redundant or will not be a failure in the will not create a failure in the mathematics, unless otherwise the system is stressed. System is stressed, right? But there may be 10% chance under which the system operates under stress condition. And nowadays, we always want our system should be under stress condition, because we want to reduce cost everywhere. If a transmission line is there, it was supposed to carry 500 megawatt, we will try to do something so that it will carry 1000 megawatt. So, we are operating the system under stress. We also as a human being who are operating under stress. Earlier, you used to come to the institute at 9 o'clock, go at 4 o'clock, you are happy, everybody happy. But now, you have to do research, you have to teach, you have to bring project, you have to do this thing, otherwise your entity will not be there in the institute. You may be driven out after 1 or 2 years. This is what? This is due to the change in the society, operating condition, everything, you are under stress condition. Okay? So, under stress condition, the assumptions becomes invalid. So, the mathematics which I have derived is now incorrect. So, since the mathematics is incorrect, my controller will also be incorrect, or whatever designing I am doing using that mathematics will be now incorrect. Therefore, I need a proper system, and that can be done with the help of neural network, which is or which will be trained with the help of a data set. Now, if I am taking a data set, I am doing the experiment on the system itself, which is operating on the stress condition. I will take a DC motor, I will put the higher required load, and I will operate the machine under stress, and I will take the data. So, inside the data, all the intelligence are already there, all the informations are already there. So, since it is directly from the system, it takes care of all the assumptions, right? So, now if I will design a controller or any operation using that data set, it will be more accurate compared to that of the mathematics. So, these are some of the advantages of neural network. I will come to the neural controller when I will teach in the end of this total lecture. Okay. Now, coming to the fuzzy systems, because I have also been told to discuss about fuzzy systems little bit. Now, suppose you are looking to a person and you are telling that he is a tall person, right? How do you know that he is a tall one? Huh? By comparing to yourself. By comparing to yourself. But you see, you are not going and measuring the person with a tape or anything. So, a 6 feet person is supposed tall for me, maybe dwarf for another person. Suppose the person itself is 6.5 feet. Will definitely tell that 6 feet is a tall one, right? But for me it is a, or he is a tall person. Now 5.9, 6 feet is tall. Okay, 5.9 tall, 5.8 may term will come into picture, 5.7 hesitation will come into picture, 5.5 no, I cannot tell that he is a tall, right? So 6 feet is definitely tall, means he is belonging to the tall category with absolute tall, 100%, no doubt. For whom? For me, not for you. So I as the expert, just like you went to the doctor when you are feeling problem, you took the advice of the doctor, means you took the advice of the expert. So like that, I as an expert, when I am designing the fuzzy system, for me 6 feet is 100%, 5 feet is 0, and in between I am doing some business. I may categorize them in a linear zone, I may tell that it is a trapezoidal, I may tell that it is a Gaussian, many things can be made, right? For example, if I am telling 6 feet is 1 and 5 feet is 0, and I am uniformly reducing them. That means 6 feet 100%, 5.9 99%, then 95%. So like that I am giving. On the other hand, which I was discussing, what I was telling, I was telling like this: 6 feet 100% tall, 5.9 is also tall, 5.8 tall, but then I am coming back. So this becomes a trapezoidal. So like that you can formulate any of the representation you would like to. Okay, so that depends on the expert. right? So this has lot of advantage in the sense that it takes care of uncertainty into